Hello everybody and welcome back. My name is Brendan and today we're going to be going over how to solve math problems with variables. Now one of the first questions of course is what exactly is a variable? Now a variable is something that we actually work with quite a lot even though we don't always realize it. Anytime that you have a number that is missing from a problem, that number is what's considered a variable. So the question that is at the end of any math problem could be considered a variable. Like if you have a question like say, oh, what's 3 plus 5? The answer to that question is currently unknown, and so that would be your variable. So then once you know 3 plus 5 equals 8, you know what your variable is. Now, when it's not just the answer to the question, but is actually part of the question itself, that's when it's located anywhere within an equation that a number should be. And that's the most common point where we actually consider it a variable. So for example, we have these two questions. We have 3 plus an unknown number, or our variable, equals 10. And then another variable times 5 equals 45. So those are two numbers that are missing from our equation that help us answer the question. So whenever we're working with an unknown number, we're more commonly going to see it represented as a letter or a symbol. So rather than having a question mark or a box, they're going to put something in there like, say, n or m. So 3 plus n is equal to 10, or m times 5 is equal to 45. And then, of course, we know then that n is equal to 7 and m is equal to 9, because 3 plus 7 equals 10. And m, or 9, times 5 is 45. Now, in that case, if there is any other situation where we have more than one variable, it still is technically okay. There can be any number of variables in an equation, because that's actually how we create mathematical formulas. Now, people oftentimes wonder how on earth that could possibly be right, but take a moment to think about it. There's a lot of different formulas that all use letters or symbols. Some of the most common ones that you'll see are ones for, say, solving the area of a square or finding the sides of a triangle, graphing. One of the most common ones is one that was used by Albert Einstein, E equals mc squared. Those are all letters that are used to represent unknown numbers or variables. So how do we solve for unknown variables? Well, that just depends on how many there are, and depending on the context of what you're asked in your equations. Most commonly, if you're only having, say, one or two terms or places where you have numbers and variables, then most oftentimes what you're going to do is rewrite the problem to isolate the variable to solve it. So for an example of that, let's take a look at this. So we have 6 plus n is equal to 8. Now the easiest way to make that work, let me pull up my pen real quick here, is that instead of just considering it as 6 plus n, we consider it as a positive 6 and a positive n. And in order to get it to where we isolate our variable, we're going to make it to where the n is by itself. And so we're going to do that by moving the 6 from one side of the equal sign to the other. In order to do that, we're going to take the 6 and we're going to flip its polarity on itself. So instead of it being a positive 6, we're going to subtract it from the side that it's on. And when we do that, it cancels it out, and then we're going to move it to the other side. So then it goes from being 6 plus n to n on one side, and then 8 will become 8 minus 6. So now we have n by itself, and we have an equation to solve. So 8 minus 6 equals 2. So n is equal to 2. And we know that that works because we can double check our work by just plugging the number back into the formula in place of the letter. So our variable is 2, so 6 plus 2 equals 8. Let's take a look at another one real quick. Maybe a little bit more complex. This one, we have 8x minus 12 is equal to 12. Now, again, we're going to be focusing on isolating x, but there's a new situation that we have to consider. We have 8x instead of just x. So 8x is a situation meaning that 8 is multiplied by x, or x is multiplied 8 times. So what we're going to have to do at some point is we're going to have to separate the amount of x's to where there is only one. But first, we have to get rid of the other part of that equation. So the first part that we're going to have to get rid of is the negative 12. So of course, to do that, we're going to add it to both sides of the equation. So then our equation goes from being 8x minus 12 equals 12 to 8x equals 12 plus 12, or 8x equals 24. Now that we're at this stage, we have to do things a little bit different. We now have to figure out how to get 8 off of the x. Now, the simplest way to do that is that we know that it's 8 times x, and so we're going to divide both of them by 8. And of course, we're going to do that on both sides so that we get it moved over. So if we divide 8x by 8, we've dropped down to a single x. So now, x is isolated, and 24 is being divided by 8. So 24 divided by 8 becomes 3, and x equals 3. And of course, we can test that again by plugging the number back in. So 8x, or 8 times 3, is 24, minus 12 equals 12. So far that's pretty simple for working with variables. But there are situations that pop up where you don't have a need to find an answer. In those situations, you oftentimes just have different terms with variables. When you have that, it's often going to be 2 or more different variables that don't have direct answers. At that point, you combine the like terms. So let's take a look at an example of that so that we know what that means. Here we have 3a plus 4b minus 2a plus 3b. Now to write that out in a simpler term, we're going to find the like terms. In this instance, 3a and 2a are like terms, as are 4b and 3b. Now when we're going to combine these terms together, we have to keep the sign that was right next to them. You'll notice that we have a positive 3a, and then we have a negative 2a. So when we combine them, they are going to be 3a minus 2a. So we line them up so that we can make them work out simpler. 3a minus 2a is going to become a, or 1a, and 4b plus 3b is going to become 7b. So that is how you would combine like terms when working with variables. Now let's go over how you will often see variables in most math questions. One of the first things that you usually will see is something like, solve the following equation, a minus 12t plus 35. And then they'll tell you that your terms are a equals 10 and t equals 5. So they've given us our two variables right out the gate, 10 and 5. So what we're going to do then to make things simpler is we're just going to plug those numbers in and solve our question. So we have 10 minus 12 times 5 plus 35. So then, following order of operations, 12 times 5 is 60, and that is a negative to begin with. So we have negative 60, and then we have 10 and 35, which are positive, which add together to become 45. So we have negative 60 plus 45, which is going to equal negative 15. So that is the first answer to our series of questions. So we're going to go ahead and erase all of this so that we still have room to work. And we're going to write our answer is negative 15. The next one, we're asked to simplify. So we have 8x plus 12, parentheses y plus 10, minus 2y minus 4, parentheses 2x minus 4. So in order to do this one, they're obviously asking to combine like terms. But first, we have to solve for everything inside of our parentheses. Order of operations is still technically applicable here. So, in order to make it work, we're going to have to start by rewriting our equation with our parentheses solved through distribution. So we're going to keep 8x, and then we're going to solve by multiplying our 12 to everything inside of our parentheses for our first one. So we have 12 times y, which is going to become 12y, and then we have 12 times 10, which is going to become 120. We keep going, minus 2y minus, so now we solve for everything inside of the next set by the negative 4. So negative 4 times 2x, we can consider as 4 times 2, and then put the x on at the end. So negative 4 times 2 is 8x, and then negative 4 times negative 4, a negative times a negative will always be positive, so 4 times 4 is 16. Now that we have that separated out, we can then start combining our like terms. So the first two are 8x and negative 8x. So negative and positive 8x will cancel each other out, so we no longer have to worry about those. The next set that we have are 12y and negative 2y. So positive 12 minus 2 will give us 10y. And then we have positive 120 and positive 16. So 120 plus 16 will give us positive 136. And we can't isolate anything else from these because 10y is a different term from 136. So that finishes up that problem. Our next one, solve for m. So we have 250, which is equal to 10m minus 150. So in order to solve this one, we're going to start by working on isolating m. So the first thing that we're going to do is we're going to get rid of the 150 and move it to the other side. Now, a lot of people ask at times, why don't we start by dividing the 10 from the n? And the reason why is because if we divided it on the one side first, then we would have m minus 150 is equal to 25. And then we would have to move the 150 over to try and solve it, and we would get a very different number at that point. So to start with, again, let's focus on the 150. So we know that we're going to add it to both sides to cancel it out, so we're going to wind up with 10m is equal to 150 plus 250, which is 400. So then we have 10 times m, which we're going to divide by 10 to cancel it out. And then 400 divided by 10 is equal to 40. So our answer then is going to be m equals 40. So now to double check that, we can plug it back in. We know that 40 times 10 is 400, minus 150 equals 250. Now just to show why we don't do the division first, let's go over it. So if we have 250 equal to 10m minus 150, if we divide by 10, and it cancels out there, 10 goes into it and it becomes 25. So 25 is equal to m minus 150. If we add that to both sides, then it cancels out here, and it becomes 175. Now, 10 times 175 would become 1,750. Minus 150 would wind up becoming 1,600. So very clearly, not the same answer. So always remember that to isolate, you work with the numbers that are not directly connected to your variable first. And now for the last one, we have a word problem where they ask us to write the equation and solve it ourselves. And they specifically say the following. Marcus has $185 to spend on books. After he bought 20 books, he has $35 left. So how much money on average did he spend for each book? Now, we can write this one of two different ways in order to make it work. Our main focuses are on the fact that he has $185, he bought 20 books, and he has $35 left. So, we can set this up with two different potential answers, or even three potential different answers. We could have it set up to where 185 is equal to the 20 books bought plus the $35. We could also set it up to where it's $35 is equal to the 185 minus the 20 books, or we could have it as the 20 books is equal to the $185 minus 35. To make things simple for myself, I'll usually write the 185 first, because then I know that that's the total that we end up with between the 20 books and the $35. So we'll write 185 is equal to 20, and we're going to put B for book price, plus the $35 that were left over. And now we're going to solve that. And of course, first things first, we're going to get rid of the 35 on both sides. So 185 minus 35. 5 minus 5 is 0. 8 minus 3 is 5. He has $150 left and 20B. So if we divide both sides by 20, then we're going to wind up with our answer. Now, something that makes things easier when you're dividing, if you have two zeros at the end, if you cut that off, then you wind up with two equilateral numbers to your system. So now instead of having to work 150 by 20, we only have to work 15 by 2. Looking at it and knowing that 15 is not an even number, I'm going to go ahead and put a decimal there. Now, 2 goes into 15 7 times, leaving us with 1 left over. bring up our decimal, and 2 goes into 10 5 times. And so that's 7.5 or $7.50 that was spent on each book. And so our answer then is $7.50 on average per book. And that should, for the most part, cover every situation that you will normally come across when using variables. In another video, we'll discuss more about how variables work for formulas, but for now, this is the basis of what a variable is and how it works. If you have any questions, you can always look further into things, or you can send a message. Thank you so much for tuning in, and enjoy the rest of your day.